All right, everybody. So I may have said this the other day, but I'm going to say it again because I don't know if I said it for everybody, and I haven't said it for the people at home yet. But so current is a measure of how many electrons are flowing. When we were doing the Van de Graaff with the static electricity, that wasn't a whole lot of electrons. It just hurt like a little bit, but like in the wall, there's a lot of electrons. If you've ever been shocked by anything like the wall electricity, then that hurts more, and it can be very bad for you. So don't do that. But yeah, that's about how many electrons are flowing. That's current. Current, like water current, right? It's a good analogy to use water as an analogy for that. You know, more water molecules, just like there's more electrons. That's more current. More current in the river because there's more water molecules. More current in the wire. That's measured in amperes. Is a French guy, and named after a French guy. Amps for short, and capital A for an abbreviation. So like, you know, you might see the wall say 15A for amps. Most of those, the regular wall plugs can do 15 amps. And the Van de Graaff's safe because it has very low current. That's microamps, milliamps, something like that. Resistance is a measure of how difficult it is for the electrons to flow. The warmer the wire is, the more those wire molecules, the metal molecules in the wire are moving around, and it's harder for the electrons to get through there because there's more collisions, more energetic collisions between the electrons and the thing, so that's bad. And there's other things, but I don't want to get it wrong, so I'm not going to say it. But it's measured in ohms, who's a German guy, and studied electricity. All of them studied it at about the same time, except for, who was it? The volts guy did it before these guys did. So ohms is a measure of resistance, and you could say, 9 ohms or something. You may have seen it on speakers. Speakers need low resistance because it makes the sound quality better. Because if you have a wire with more resistance, then the information going through that wire in the form of patterns of electrons, the patterns can get messed up if there's more resistance, so low resistance is better for the speakers. You may have seen that symbol. That's a Greek letter omega, or omega. I'd like to say omega because that's what James Bond says. And that's a capital Greek letter omega, and that's how you say 9 ohms. So if you see that, that's resistance, ohms. And yes, how difficult it is for the electrons to flow, we said that. Voltage, measured in volts. Volta, the guy, Alessandro Volta, he was an Italian guy. I like to say Italian. And volts is a measure of how easily they'll flow. Another word for it is potential difference. If you have a bigger difference in electric potential between 2 points, then the charge wants to flow there more. Like when we were doing the Van de Graaff, or if you've ever built up static electricity at home and then shocked a doorknob or whatever, your electric potential and the doorknob's electric potential is very different. So that's why the charge jumps, because there's lots of volts in between you and them, because there's lots of potential difference. And that's why potential difference is another word for volts. Another term for volts is 2 words. And that's volts with a capital V. You have 9 volts, or 12 volts, or whatever. 12 capital V. It's how much the electrons want to flow. Like, I don't even know how many volts are in lightning. We haven't had any lightning. But I'm in that lightning group. If you have any coaches here, they can tell you they get an email anytime there's lightning, because they got to know when to get everybody inside if they're out for practice or game or whatever. But that email, the sensor that the school has that sends that alarm off, sends an email out and sets the alarm off. It actually measures how many amps, how many electrons are flowing through from the clouds to the ground or whatever, and I don't know if it measures how many volts. Maybe it does. But if there's lightning that goes all the way from the cloud to the ground, that's a whole lot of volts. Because it really wants to go so much that it goes through the air. The wall volts don't do that. It doesn't come out of the thing through the air and touch you. It has to have metal to do that. Cool. Yeah, the rest of this stuff is on there. There's the formula V equals IR, so it just says how these things are related. If you have a high voltage, that means that one of these or both of these is high. If you increase the resistance, that means the voltage goes up. If you keep the voltage the same and you increase the resistance, that means that the current must go down. The two that are next to each other are inversely proportional, so if there's more resistance, there's got to be lower current, or if there's more current, there's got to be lower resistance. And if they're on opposite sides of the equal sign, that means they're directly proportional. So if there's more voltage, that means there's more current or more resistance. Or more what? I think that's all y'all need with this. Please try out this assignment, Ohm's Law.